Bang, bang, shoot 'em up, destiny. Bang, bang, shoot 'em up to the moon. Bang, bang, shoot 'em up, 1, 2, 3. 1, 2, 3, 4.
Hello everyone, welcome to JAPL, a very small company with very big ideas. I'm Alan Phillips, the resident electrical philosopher, and today we're going to discuss space habitats. America's grand vision to land humans on the moon in the 60s inspired generations of people to look outside of themselves and to work for a better future. Even one photograph from that period, known as Earthrise, caused people to realize we are all connected and our futures are linked. If mankind is going to successfully become a space civilization, we will need to be able to work in zero-G for long periods. Introducing the BoLo YoYo, a cost-effective, mobile, spin-gravity habitat. Many of us have been inspired by the images of futuristic space castles that we have seen in Star Trek, Star Wars, and The Expanse. Also, however, many of us are unaware of the cost and logistics of such monumental undertakings. Many projections indicate it may require decades within the economic capability of our current society to build even one. Today we're going to discuss the BoLo YoYo space habitat, a feasible alternative to the generational effort necessary to build one of those glorious structures. Mankind has discovered over the last 50 years that it cannot survive long periods of weightlessness. Many types of artificial gravity have been proposed. What are the options? It appears that in the foreseeable future, the only practical way to provide enough stress on the human body to maintain health is by a large spinning structure. Humanity's future as a spacefaring species, even inside the solar system, is not a foregone conclusion. It will be extremely difficult. The BoLo YoYo space habitat design can contribute. It overcomes the harmful effects of long-term exposure to microgravity by providing an Earth-normal spin gravity force which is no more detrimental to health than what sailors today experience at sea. The design is minimalistic in cost, and the logistics requirements are less than other systems. The settling of the solar system will be difficult, and success is not guaranteed. Experience has shown that difficult undertakings may have to bootstrap themselves, and that underfunded projects that overspend on lofty goals can become bankrupt and never completed. So, what are our issues? Critical paths are like a chain. Each element requires the successful completion of every other element. Important projects have critical paths, especially if never done before. They are at risk. All unnecessary steps must be eliminated, and each critical step must be accomplished. Establishing a successful space civilization has many requirements, and creating a healthy zero-G environment is one of them. Understanding and overcoming the restraints of funding and the logistic trains are equally important. Enough about me. Let us listen to what the person with the most rockets has to say.
I think generally manufacturing is underrated and design is overrated. So people generally think that this eureka moment of you come up with this idea and that's it. Now it's good. But the design, there's literally 1,000%, maybe 10,000% more work that goes into the production system than the thing itself. So say how much effort have we put into, say, designing Raptor versus designing the manufacturing system? It's 10 to 100 times more effort to design the manufacturing system than the engine.
Even of Raptor?
Oh yeah, absolutely, especially with Raptor. I can't emphasize enough, I'm trying to correct the misperception that design is the hard part. It is not the hard part. This is just very fundamentally underappreciated. If people have not been in manufacturing, especially manufacturing of something that's relatively new, then they don't understand, and they think the design is the hard part, and they think production is like a copier or something like that.
Right.
This is completely false.
Admiral Hyman Rickover personally designed and supervised the construction of over 200 naval vessels and their nuclear reactors. Let's see what he has to say of his experience comparing theoretical design and practical manufacturing. An engineer at JAPL worked for Rickover and participated as shipyard duty officer in the construction of the USS Alaska, a Trident submarine. The construction of the Alaska was essentially the assembly of material manufactured elsewhere. Work teams lived locally and did not require support. The final tally of our effort building the Alaska came to over $10 billion and 15 million man-hours over a 4-year period. This experience with a significantly large and complicated industrial project gave the folks at JAPL an appreciation not only of design, but of manufacturing, and also of logistics. The effort was on the scale of the construction of a 100-meter diameter space station, but without considering the cost of logistics. What are the costs of logistics, and why is it important? They are the costs of supporting the primary effort. At the naval shipyard, the vast majority of the cost of logistics was already paid. The utility and worker housing infrastructure was in place. We didn't have to create food and ready spare storage. Warehouses and grocery stores are already in place. Small shops or FedEx could provide the inevitably needed missing part. Not very sexy, but all of which must be provided and carried into space. Logistics is the underappreciated stepsister of construction and manufacturing. Example: Bill Boeing built aircraft near JAPL for decades and demonstrated that for every person on the assembly line, there were about 3 people in support staff, and that for every Boeing worker, there were maybe 5 people providing uncontracted benefits, anywhere from supermarket employees to electricians, plumbers, and general construction of housing and infrastructure. And for every one of those community members surrounding the industrial base, they would need support: food, water, housing, transportation, i.e., staging and logistics. To summarize, it is extremely difficult to get into space. It is extremely costly to get into space. To be successful, we must prevent the health issues caused by zero-G. To be successful, we must be mindful of the hidden costs of logistics. To be successful, we must focus our efforts on the critical path. To be successful, we must minimize the scope of our projects to the minimum required. Well, let's hear what Elon has to say about streamlining our critical path.
The fundamental thing, over and over, it's like the tendency is to complicate things. And I have another thing, which is like the best part is no part. The best process is no process. It weighs nothing, costs nothing, can't go wrong. So the thing I'm most impressed with when I have the design meetings at SpaceX is, what did you undesign? Undesigning is the best thing.
Experience indicates that good engineering practices, where the project is limited by cost or orbit mass, requires elimination of all non-essential parts. What can we remove from the space station of the movie 2001 and still keep its essential parts? We must maintain living spaces and spin gravity for occupation and health. And when done, we need to be compact and low mass. We can replace pressurized structural tubes with cables and maintain stability with AI control thrusters. We can eliminate connecting corridors. It will be like replacing a brick and mortar house with a small mobile home and minimizing the size of the kitchen, bath, and living quarters. In fact, it will require that spaces, like in a mobile home, be multi-purpose. We will call it the BoLo space habitat. Why do we call it the BoLo? It is because the system can independently move and the habitats are rotating around a common center on tethers. The tether system can create the spin gravity necessary for human health, allowing for long-duration interplanetary travel or in-space industrial manufacturing. The natural torsional instability of a tethered system has been resolved by the use of modern AI thrust control at the 2 end terminals, i.e. the BoLos, which are our pressurized habitats. The tethers. Using stainless steel aircraft cable, 3 1-inch diameter cables can support 2 fully fueled Falcon 9 second stages or 2 unfueled starships, 1 at each end of the tethers. An advantage of the BoLo is its capacity for powered flight. When the tethers are retracted and using starships or similar rockets as habitats, the BoLo can travel to asteroids or achieve orbital velocities for interplanetary travel. During the non-powered flight, the habitats can be spooled out and rotation achieved to create the spin gravity necessary for transit.
Yeah, you might take it as like gospel, like
Yes.
I have to do this thing.
Everyone's wrong, no matter who you are. Everyone's wrong some of the time. So make your requirements less dumb. Then try very hard to delete the part or process. This is actually very important. If you're not occasionally adding things back in, you are not deleting enough. The bias tends to be...
Now that we have reduced a space habitat to the minimum, what should we add back in? The essential missing part is a king post. What is a king post? It is a solid rod supporting both tethers at the center of rotation. This allows the tension of the tethers to be converted into compression within the kingpin, thereby reducing the total strain on each tether by 50%. This has a cascading effect, allowing the tether mass also to be reduced by 50%, and thereby allowing the reduction of the mass of the other strength members within the rotating system, reducing the mission fuel requirements, which allows for fewer support launches, etc., etc., etc. You know, logistics, reducing the total cost of manufacturing, critical path and all that. Should we add anything else back into our BoLo system? Adding additional components and capabilities to the BoLo is not necessary, nor initially desired, because it will add cost, weight, and complexity. However, an advantage of the BoLo is that it is fundamentally a flexible and scalable system. When feasible and desired, a central truss core can be added. This core can have added capabilities such as solar arrays and increase living space by moving mass, such as fuel and supplies, to the central core. This also reduces the weight of the habitats and thereby reducing the requirements of the tether system. In the collapsed configuration, the rocket slant habitats can be mounted to the central core for powered flight. We have named this core the YoYo and the complete system the BoLo YoYo. Some people communicate best using a written word. Others are more visual. The following is a computer graphic describing the BoLo YoYo system. Let's talk about the advantages of the YoYo. It is incredibly difficult to launch heavy mass into orbit. A lightweight design is critical. The problem can be expressed with 3 words: logistics, logistics, logistics. We need to pursue the system that provides usable spin gravity for the least mass. The BoLo YoYo space habitat is a solution. The lightweight center of the habitat is called the YoYo. The essential part of the YoYo is the king post. A proper king post can reduce system mass by 50%. This is followed by every engineer's favorite part, trusses. Trusses can create a variety of strong, lightweight skeletons. This provides a framework to carry expedition supplies, reducing the mass of the tether system in the habitats. Stored within the cage can be spare oxygen, extra fuel, and oxidizers, essential water, food, and spares. Attaching hoists to spool out the habitats, then attach the habitats themselves, in this case, SpaceX starships. However, the habitats can be from any manufacturer or even a mixed group. When finished, we have created a spin habitat that is completely mobile. Why do we want spin habitats? because people cannot survive long durations in space. A spinning habitat creates synthetic gravity at the perimeter. The amount of artificial gravity is based upon the rate of spin and the distance from the center. There are a number of trade-offs for comfort. A comfortable 1G environment can be created at 1,000 meters. For space settlements, the BoLo YoYo is a solution. At this point, the BoLo YoYo can be enhanced by adding back in a cable crawler. This will allow crew movement between the habitats as well as rotation on and off station by way of tug transfer from the yo-yo. In addition, the crawlers will allow supplies to be brought to the habitats from the yo-yo. By moving most material to the center, we can minimize our outward forces and reduce the size and mass of the tether system. Crawlers need to be in pairs and move opposite to each other to maintain angular momentum. Crawlers also must move slowly to reduce cable hysteresis loss. An additional advantage is that the yo-yo truss system is inherently flexible. It is adjustable in shape, scalable in size, and can be repurposed endlessly. The habitats are not restricted to manufacture or nation of origin. Different habitats and their masses can be accommodated by changing the tether length. The system rotational forces will then stay centered on the king post. Different ship configurations can be accommodated by changing the strongbacks. For space travel, the BoLo YoYo is a good solution. We know that heavy industry in orbit will be essential. For civilization to be established in space, space itself must provide the materials. Rubble asteroids look like a promising source of ore, possibly already segregated by density. Another requirement, power. Solar panels are a reliable generator of electricity. Located at the center of rotation where the stresses are minimized, panels can be sized to meet requirements, and then the power transmitted to the habitats. Due to presentation needs, we have drawn these panels smaller than anticipated. The primary purpose of the BoLo YoYo is to provide the necessary spin gravity for workers. This will allow for the long duration stays necessary to establish our space industry. Adding a pad for shuttles at the center of rotation will minimize the stresses that occur when docking arriving spacecraft. This pad will allow work shift transfer between the habitat and the work site, as well as crew replacement and augmentation from Earth. Placing a yo-yo on station near local asteroids will enable the development of industrial work yards. This will not be easy. It will likely need the implementation of smart tools, which are discussed in another publication of JAPL. This will include the complex and sophisticated crafts of extracting, refining, smelting, rolling, stamping, and the forming of the ores necessary for structural elements, as well as the processing of the delicate substrates required for electronic manufacturing. For space industry, the BoLo YoYo is an excellent solution. The BoLo YoYo space habitat can do even more. It can provide a central watch station for continuous safety monitoring. History and experience have indicated the need for constant alertness, whether it be for the perimeter of tribal camps or submarine patrols deep in the sea. Shuttle terminals allow for the habitats to remain on continuous duty, yet also allow for the BoLo YoYo to migrate to new solar system locations as necessary. Ballast control allows for reconfiguration of the entire system without the need for system contraction, bringing the habitats back into the yo-yo. Note, we can build living quarters beneath the surface of a rubble asteroid like Bennu. This will reduce the number of transfers necessary, increase crew efficiency, and also be able to provide emergency shelter during radiation storms. In conclusion, the minimalistic BoLo space habitat is a stable 1G environment. When the BoLo is augmented by the YoYo central core, it becomes significantly more capable. It is cost-effective and is more logistically feasible than other designs. It is simple, made from trusses, which are easier to ship and assemble. It is flexible in design, capable of simply supporting just 2 habitats, or as many as 8 in the design shown. It is scalable even bigger than shown, possibly with its own propulsion. Boosters can be added and jettisoned to extend its range within the solar system. It is a reusable mobile platform, good for the mission to Mars and other planetary travel. It extends on-site time for asteroid mining and industrial work. It can be reconfigured as mission requirements change. And finally, we can build it. It is not a pipe dream. The BoLo YoYo space habitat is a good solution. In conclusion, the folks at JAPL think that the protection of life and humanity is the most important purpose in the universe. As part of that purpose, we think that creating a space civilization is critical. Besides doing research, JAPL conducts outreach in support of our goals. People with concerns generally ask 3 main questions. They are: why even go into space? Why take money away from other deserving needs? What has the space program done except feed the egos of the super rich? JAPL thinks these concerns need answering, and that we need to conduct ongoing public educational outreach. Hopefully, the next section will partially fulfill this need. Question number 1. Why even go into space? Well, have you ever had a discussion about the future? Maybe about your future? Maybe about the future of the planet? It seems that every generation is confronted with extinction, and the previous ones have barely escaped it alive. How will our grandchildren survive in 50 years? How will humanity survive in 5,000 years? Did the other person even have a real plan? God has made a plan for your immortal soul, but how can we do better for Earth until that unknown day? JAPL has a plan, and this video is part. What is your plan? Now, to question number 1. Why create a space civilization? There are 3 answers. Originally, people pursued increased knowledge through the exploration and discovery of the solar system. Newton's understanding of physics and gravity, which allows us to make cars and airplanes, came from the study of the orbits of the planets. But after the publication of the Earthrise image, people saw how vulnerable Earth was, and began considering space as an insurance for survival of humanity and of life itself. And perhaps most important, the hope and inspiration from doing something so incredible and important gives us the strength and courage to march into the future unknown. Let's talk exploration.
Bang, bang, shoot 'em up, 1, 2, 3. 1, 2, 3, 4. I wanted to be a spaceman. That's what I wanted to be.
Let's see what William Shatner has to say. Remember, when he started making Star Trek in 1966, all across the world, most people had never been more than 500 miles from where they had been born. The vast majority of Americans had never been in an airplane. Less than 30 people had been in space, and not one person had been more than 500 miles from Earth, much less than on the moon.
When you're up there,
At age 90, William Shatner becomes the oldest person to ever go into space.
Captain, a most curious development on scanner 5-7.
That's all. Take a look at it, Mr. Spock.
Screen on, Captain.
Captain?
is the most profound experience I can imagine.
We at JAPL know the future is uncertain, and the protection of life and humanity is our goal. Creating a civilization that is distributed throughout the solar system provides additional protection for our survival. Let's listen to Shatner and Musk discuss their beliefs in this arena.
What I would love to do is to communicate as much as possible the jeopardy, the moment you see how the vulnerability of everything, it's so small. This air which is keeping us alive is thinner than your skin. It's
The sort of deep meaning behind this, like why build a giant reusable rocket, why make life multiplanetary, and I think this is just an incredibly important thing for the future of life itself. So there's both I call it the sort of the defensive reason or the life insurance reason. That's one part of it, which is that there's always some chance that something could go wrong on Earth. The dinosaurs are not around anymore. There could be some calamity where we do ourselves in, or there's a natural disaster. Now I'm naturally an optimist, so I think the probability of that is low, but it is not zero. And
We just heard from Shatner and Musk the reasons why creating a space civilization protects life and humanity. Additionally, and significantly, it inspires, it creates hope. We are investing in our future. Let me summarize our message in a simple story. Imagine a seed, a very small vessel with a heart of hope, and a small gift of food from a previous generation. If it does nothing, it will dry up and die. If, unfortunately, left in darkness, even using its gift, it will die. But if given sunlight when it's ready, it will take the risk and invest that gift to send out a very small leaf. From that small leaf, it will use the energy of the sun to make another leaf and to send out a small tendril into the soil to make a foundation. With 2 leaves to work with, even if it has used up its initial store of energy, it can bootstrap itself from the sun's bounty to 4 leaves, then 8. By investing in the future, even a poor seed can join the next generation of forest giants. Can we, humanity, risk investing part of our limited resources on our space program? How can we afford not to? Space is the seat of our future. Tim Dodd says it another way.
Even more this year. And to me, that's really what this is all about. It's not just about pushing the boundaries, making scientific discoveries, or standing on new worlds. It's about uniting us under a common bond of exploration and excitement. There's a feedback loop in play here, and I hope you all understand your role in it. By tuning into these events, by cheering for the scientists and the engineers who make this all possible, you are helping foster and create an environment for future generations to want to take part in. To those of you parents who have kids at your side as you catch up on space news, or to those teachers who stop their usual lessons to witness spaceflight history, or even to those of you who have traveled vast distances to witness a launch in person, you are making the difference. I can't even begin to tell you how many people I've met that have changed their career paths and are now literally building rockets or developing spacecrafts or doing planetary science, all because they happened to catch the bug. This is what truly propels us into the future. A society excited about the next step, eager to work on something historic and meaningful, and a growing workforce who has been inspired by others to do great things.
Thank you, Tim Dodd. That was awesome. The second question was, how can we afford the cost of going into space? This is a good question. We are definitely confronted by limited resources. Underlying this question, however, is a false assumption. It is called zero net sum and means there is a fixed amount of resources available. Giving money to the space program means less for everyone else. Not so. Not all endeavors are fixed. Farmers invest part of their harvest as seed stock for the following year, even though it will mean less bread this year. Communities take money from people to invest in schools, even though not everyone has children, even though the positive results do not appear for decades. Both school and agricultural investments pay back much more than they cost, and we all benefit. This is net sum positive. The space program has been significantly net sum positive. Remember the seed? Seeds are net sum positive. They get back more than they invest. The third question JAPL gets asked is, come on, really? What have the space programs done for us? Investments in space have contributed greatly to society. Really? We see on the news men in spacesuits, but the reality is far greater. Consider the original investments by the government to develop lightweight controls for spacecraft paid the steep costs of the original research to create the miniaturized electronics required. After a few decades, this initial investment blossomed into the electronics we use today. Here are some examples. GPS allows us to predict volcano eruptions like Mount St. Helens. The CAT and ultrasound scans at the hospital would not exist without the electronics revolution. Businesses have become more efficient by at least a factor of 10 with barcode scanning and accounting software. The design and manufacturing of the turbine engines of our passenger jet fleets would never have happened. Agricultural production would have flagged population growth, not to mention material science improvements. Investments in space have contributed greatly to society. Really. In summary, JAPL wishes to thank you for listening. We really do. We think that creating a spaceborne civilization is an investment in our future, a backup plan, and an inspiration. As a component in this venture, the BoLo YoYo space habitat can contribute because its minimalistic cost complies with the critical path requirements, its scalability and flexible design allows future planning and use, and it provides a healthy living space within a zero-G environment. JAPL would also like to thank their sponsors and contributors. JAPL believes that hope is real, not wishful thinking. Real hope is based upon observation of reality, observations that show that entities working together survive. Real hope engages the fundamental areas of our brain. Real hope gives the energy, the courage, and the fortitude to fight the good fight, to struggle against entropy, to survive, to aspire, to grow, and to thrive.